I'm Roman from Pen Tested. We are tackling practical information security, and I'm going to speak about this bypass of I can't seem to figure it out with the remote control. So talking about the analysis in the WAF and WAF, HTTPF traffic, we're talking about signature analysis, as you know, and machine learning has been used quite heavily. For a major part of people, machine learning still remains a kind of a marketing feature. So there has not been much trust developed to machine learning, and I would like to unveil this myth. So this signature analysis has two deficiencies. So of course it's fast. It's very fast, but it has two major deficiencies, lots of false positives and skipping attacks. So to make sure the WAF works well, they try to balance, the developers, and they make signatures more aggressive and they make it less aggressive and they're skipping attacks. This example I'm going to show is simple. We're talking about PHP select. Two operators have been used in this SQL injection. So if this rule had been developed poorly, select or org are used here. So what's going to happen here? There'll be the blocking and the false positive will initiate. As far as skipped attacks are concerned, I'm going to talk about this recent vulnerability, log4j, and initially we're going to take this first string, and this is what it looks like, JNDI, etc. So some of the developers had started writing this kind of signature, it would block it, and then it had been known previously that instead of LDAP, some other protocols, TNS, LMI protocols can be used here, but after those signatures had been created, we have some bypass methods emerging. So the attackers may dissolve the code somehow, so this payload actually initiates at the end instance, but at the same time it would bypass the signatures. So in red it's been highlighted like that.
So this means that the signatures are not ideal, but we will come back to this. So let's do it in order. First of all, we split the payload, the request. We use the command symbols, asterisk, slash, the commas, the brackets, no byte symbols. Plus, for most of the applications, you know that plus and the space are the same. But if we talk about something more smart, let me show you. So the construct is like this: cell plus act. What does this structure bring us? If the WAF takes those bad words from the request, then it will remove the select. But after it cuts off the select, what we will get? We'll get another select. And this is how you might try to bypass this. Also, URL encode is used, you know what it is. But WAFs usually normalize this to ordinary UTF-8 text Latin, or whatever it sees after the decoding. But What if we do a double or triple URL encoding? This will depend on the amount of iterations that WAF has for encoding. If we do 2 encodes and the WAF decodes only once, then we can bypass it. Let's move on. We have some time, right? Couple of words about XSS. Quite often you see the signatures written as constructs. So if you expect the tag to be closed, then some tags would work without closing. Also, the old technique of using non-registry dependent symbols in different registers. So besides that, we often see using the usage of other than UTF encodings, UTF-8 with X, 16, 32, half and full wide forms. It would look like the ordinary Latin text, but with the spaces in between. But this technique can work, and it works with the where operator for databases and another constructs, base64 and your own codes that I mentioned. To be more visual, I've prepared a number of screenshots to give you. The alert is split. Something similar happens in the next screenshot with a prompt. P and R are represented as UTF-16 symbols, but the technique, at least based on what the author says, works fine with this WAF. Maybe it has a mistake. Next, with Amazon, quite an old screenshot. You see an attempt to add to an XSS payload an exclamation mark, and then the bypass is there. Who will guess what happens here? What is lacking here? Yeah, there's no I letter. So in the payload of scripts, confirm script, there's no I. And we have a pgspell function, pgspell suggest function. That's something like T9 in PHP. It will complete the construct to script confirm script, so the WAF will be bypassed, but the payload will successfully work in the web application. Did you get it? RC and OSCI. This all has to do with bash. When the application sends something to bash and it works as an AND interpreter, and you can split the requests. So a very famous one is a bin cut etc. password that with replacements with the question marks. But if you send this construct to bash, it will work. But how would you create a signature that will work on this class of bypasses? Can you create one? What will we put in the signature? Too many question marks or something else? So I'll come back to this example to give you some ML context. And with cat etc PSWD, then we do not initialize a variable, and it's been cut, and then it runs in bash. So machine learning, couple of words. This is separate presentation, and ML specifically works based on not on some specific static data or principles, but based on the features. If we prepare and add to the data set the attacks that we need, then it will understand that similar attacks that look like this will work. So it enables to block the attacks that cannot be blocked with the signature methods. So if do you know how to understand that it's machine learning? If it's written on Python, then it's probably machine learning. If it's in PowerPoint, then it's AI. So how do you check? How do you check the WAF bypass? There is a set of Python scripts and a Docker image can be downloaded. There's a lot of payloads, encodings, and tools. And it can let you check your own WAF. Am I in time? Thanks. Please feel free to ask your questions, and I'll be here, so no worries, we can chat afterwards. Questions, please.